You're watching Power Nation.
Today on Engine Power, we are on the Special Projects unit where we cook up a 632 cubic inch big block Chevy to be a big torque, high-tech, pump gas tire killer.
In today's show, we're going to start the transformation, getting this engine prepped and into short block form with some high-tech parts and a little bit of bling to get it ready for its new modern muscle truck home.
Hey everyone, welcome to Engine Power. This is a brand new season, a brand new episode, and a brand new engine build. But the engine itself, not so new. This engine has been kicking around our shop for a long time and has been in a couple of different configurations, from a race gas burning engine that makes well over 1,000 horsepower to a rot gut pump gas burning engine that just is a good street bullet. But today, it has finally found its final purpose.
Today, we're going to take this big block Chevy, which is 632 cubic inches, and we're going to put it in its final form. So this engine is 4,600 bore, 4,750-inch stroke. It's based on a Gen 6 big block Chevy block. But like Pat said, it has had several different parts run through it throughout the years. And today, we're going to put even more parts in it and get it ready for its final life as a sweet street engine. So before we get started, we're going to show you how this engine started out, how many parts we've run through it, and then we'll get into what we're going to do today. The first time you saw this engine, it was being set up as a high horsepower mud truck bullet with over 15:1 static compression ratio and produced 1,022 horsepower and 821 pound-feet with an RPM ceiling of 7,500. A blueprint tall deck 4,600 bore big block Chevy engine block set the foundation and was filled with a 4,750 stroke forged crank. A set of H-beam 6,700 long rods and 42cc dome pistons rounded out the short block, along with an aggressive solid roller bump stick driven by a Jessel timing belt drive. AFR 385cc aluminum heads topped it off, and Jessel Sportsman 1.8 ratio rockers actuated the valves. An Edelbrock Super Vector 2 finished the induction with a Holley 4500 Sniper throttle body to make those big numbers on the dyno.
In the second version, the engine was tamed down into a high-torque street monster that can eat pump gas and blow the tires off of anything. The dome pistons were swapped out for a much lower compression 14cc dish for a 9.57:1 measured static compression ratio that would allow it to run on 93 octane. The camshaft was also swapped for a smaller solid roller to lower the RPM range and put the red line at 6,500 RPM. All the other parts were refreshed and reused. And on the dyno, it churned out 850 horsepower and 746 pound-feet of torque.
To make the changes we want for the final iteration of this power plant, we're going to be tearing it completely apart. Along the way, we will be inspecting everything for any abnormal wear or potential failure points that need to be resolved.
Clean one owner.
After prying off the intake, the valvetrain can be removed cylinder by cylinder, with each one set at TDC compression stroke to remove any spring pressure before the rockers come off. All the valvetrain, including the lifters, is kept organized and in order for diagnosis and reassembly later on. The Jessel rocker stands do have to be removed to get access to the head stud nuts, taking care to keep the shims underneath orderly.
All of the head studs can be loosened from the outside in and then removed from the block before pulling the cylinder heads to get the first look at the condition of the cylinders. Considering the abuse this thing has taken on the dyno, they look excellent with minimal wear and a considerable amount of crosshatch still in the bore. Making our way to the bottom of the engine, we can remove the electric water pump, crank trigger setup, and pull the harmonic damper off the crank snout. All of the ARP oil pan bolts can be removed, and the oil pan gently tapped to break the seal and lower it down.
After flipping the engine over, we can remove the oil pump and then start removing the rod and piston assembly. We'll loosen the rod bolts on that crank throw, tap them with a rubber mallet to separate the rod and cap, and then we can remove the cap completely and gently push the rod down and out of the bores. With all 8 assemblies removed, we can loosen the left-hand thread cam gear bolt, remove the timing set, and pull the crank gear off the snout with a steering wheel puller. After gently prying the timing cover off, the camshaft can be slid out. This one has specs of 274 to 84 at 50 and is set on a 114-degree load separation angle. It has a 4/7 firing order swap and lift at the valve is 772 thousandths of an inch. It looks excellent, so it will be put on the shelf for a later build. Finally, the 1/2-inch main bolts can be broke loose, zipped out, and the main caps carefully pried out of the registers so we can lift out the hefty 4/750-inch stroke crank.
All right, once again, things you look for. Underneath the cap, make sure there's no fretting. When it's fretted like that, that means it has gone into detonation. The caps are moving around, probably because it was mistuned. Everything is nice on these. Bearings look great.
I would say for the health it's in, it's really good. Probably gonna reuse a decent number of these, and then we'll just add all our new stuff.
Up next, we get this engine refreshed and rebalanced to get this rebuild kicked off.
The first thing we're going to do is tell you about all the new parts we're using to reconfigure our 632 to its new duty as a street pump gas engine. So first thing we're going to do is we're actually going to up the compression ratio. That sounds a little counterintuitive, but let me explain. We had a 14 cc effective dish on the piston, so we're going to be raising it to a 10 cc effective dome with this new Holley Power Pack piston kit. Also, we are going to go from a solid roller camshaft to a hydraulic roller valve train. So we had a new cam ground up by Comp with hydraulic roller lobes for our application, and also we're putting a set of their Comp hydraulic roller lifters in. Plus, we have to change the spring pressure in the heads. They're set up for a solid roller, so they have too much seat and open pressure. So we have a new set of springs from AFR to fit the bill, but that is just half of it.
Yeah, the big upgrade on this engine is going to be switching it to multi-port fuel injection and cold near plug ignition, because that's what the guys want for the application that it's going in. So to do that, it's actually pretty easy because parts are readily available. It's all going to be based around Holley's Terminator-X ECU. To get the manifold switched over, we actually can get one right off the shelf. This is an Edelbrock Super Victor EFI manifold for a tall deck big block Chevy. We got the matching fuel rails, and it has a 4500 flange on the top. So we have a Wilson Manifolds 2-inch bore 4500 flange throttle body with their IAC and TPS already on there. We have a set of 120-pound injectors, so we can run pretty much any fuel we want. We have a set of Holley EFI smart coils for our coil near plug ignition. And to give the ECU everything it needs as far as timing for sequential fuel and ignition, we have a Holley 36-1 big block Chevy crank trigger kit and an MSD billet cam sync because we don't need a distributor. So we just want to show you guys all the cool parts we're actually going to be installing on this, but now we actually have to get back to work.
To prep the block itself, we're going to quickly freshen up the bores with a 320 grit 4 5/8-inch flex hone, making sure to use a sufficient amount of lubricant during the process. This will give us a fresh surface finish for our new rings to seal against and clean up any minor imperfections in the cylinder. Then we can remove all of the threaded oil gallery plugs and put the block in our JRI jet washer for a thorough cleaning.
All right, so now that we have our block prepped, the next thing we're going to do is balance the rotating assembly. Because we are changing the piston, it's not too much different. It's about 16 grams difference between the old one and the new one, but we do want to rebalance the assembly to make sure that it is correct. So I've gone ahead and got a bunch of the weights all ready. I'm wrapping up now. We'll get some bob weights made, get them on our crank, and then do our first spin and see where we're at.
The CWT software will automatically calculate the bob weight for you, so all we have to do is enter in the weight of each individual component. Then we can assemble and install a bob weight on each crank pin and get our first spin going.
Not that bad. That's about what we thought it would be, being such a slight difference between the two pistons. So we are 22 grams on the rear, 12 on the front, but as far as location, front is not bad. It's right on the edge of the counterweight, but the back is going to be a minor issue just because for removing weight, you can't actually remove it from the counterweight side. It actually wants you to remove it from the rod journal side. So we're going to have to figure out a way to probably add weight to the counterweight, maybe fill in the few holes that are there, and see how close that gets us. It probably will do it for us, but we'll probably start there That way we can add material all at once and then remove material all at once.
In order to add the small amount of weight needed for this job, we will use the existing holes in the counterweights and fill them by welding them up. Using 1/8 inch ER70S filler material and even heat, we can build up a few of the holes above the surface and then grind them down flush for a nice smooth finish. This puts the heavy side of the imbalance back on the counterweight, so with a few smaller and well-placed drill holes, we can quickly bring the imbalance down within our target.
All right, we'll take that. That is 0.107 ounce inch on the front, 0.147 ounce inch on the rear. They are 184 degrees apart from each other, so they cancel out to 0.041 ounce inch on the center of the crank, so that's good. We'll save that as our last spin, and yeah, that's gonna work really good for this application. And we didn't obviously make a huge change because the pistons are very similar in size, but it's really important to have this done, because if we look at the forces on the crank from before and after, even just before, if we had left it alone, it would have been 178 pounds of force at 6,000 RPM. And now by actually balancing the crank, we've minimized that down to 9.5 pounds of force. So huge difference, even though the pistons are very similar. So definitely something that needed to be done. Now it's finished up and we can move on. Coming up, our engine gets well red. The next thing we want to do on our 632 big block Chevy is paint it, but we can't do that yet because we need to modify our valve covers to mount our Holley EFI smart coils. Now, the easiest way we found to do this is use Holley's coil relocation brackets. These are made so you can mount your coils anywhere inside the engine bay, but we can actually take them and weld them directly to our valve covers because they're made of aluminum. So what we're going to do is get these prepped, get them centered where we like, and then we'll just weld them directly to them.
We don't need the mounting tabs on the coil brackets, so to get a cleaner look, we can cut off the additional material using the bandsaw. With a flat disc, we can nicely smooth out our cuts and remove the paint from the sections we will be welding on. After cleaning the bare aluminum with lacquer thinner to remove any contaminants, we can locate the brackets where we want on the valve cover, clamp them down, and evenly tack them into place. After that, it's just a matter of fully welding the bracket in several spots to provide support, and now we have a clean and simple mounting solution for our 632's coil near plug ignition. The last thing we're going to do before we assemble our engine is get it painted. Now we're going to put some POR engine enamel on it and make it look great. But before we do that, we have to get it cleaned up so we get good adhesion. So the first thing we're going to do is we're going to clean all the parts that we're painting with POR's cleaner degreaser. Now what that's going to do is that's going to make sure the surface is prepped properly and everything will stick to it. Gets all that grease and oil out, gives us a good surface. Then before we paint it, we're going to hit it with POR's metal prep. Now that promotes the adhesion of the paint. So all we got to do is get to cleaning.
First, we will spray down all the parts to remove any debris, and then we can start applying the cleaner degreaser. This is mixed with warm water in a 4-to-1 ratio, and we can use a stiff bristle brush to give the pieces a thorough scrubbing. We don't want any oils or grease that could ruin our paint job to be left on the surfaces, so we'll go over everything twice before giving it another rinse with the water hose.
The metal prep is used straight from the bottle and can be liberally applied with a brush to all the surfaces that will receive paint. To help protect the cylinder bores and bearing surfaces, we heavily wipe them down with lubricant before we got started. But it is still a good idea to be careful when applying the metal prep. Once everything has a wet coating on it, we can let the etcher sit on the material for about 20 minutes before thoroughly rinsing it off with water. Then we can blow off the water with an air hose to prevent any rust from developing and push the parts inside to get them painted.
The first thing we will be applying is POR 15's gray rust preventive coating, which will not only cover all the bare metal surfaces to protect them from corrosion, but also acts as a base coat, giving us a uniform color across all the parts so they match when our color is sprayed down. For this engine, the color needed to be a bright, vibrant red, and POR 15's classic Ford red fits that perfectly. After thinning it out a bit with a reducer, we can load it into our HVLP gun and give the parts a few solid coats for even coverage and a smooth, glossy finish.
Stay tuned because up next, we get our big red 632 ready for assembly and show you what it's going in. All right, we are going to get into the assembly process of our 632, and because we have it so far torn down, we are definitely just going to go ahead and put new main and rod bearings in it. So the first thing we're going to do is set up our main bearing clearance. A new set of Clevite main bearings are inserted into the cleaned main caps and the main saddles in the block that Pat just wiped down. The main caps and fasteners are prepped and installed just like they would be during assembly, with CMD high pressure lube on the fasteners that are torqued to 100 pound-feet. The caps are installed starting at the back to fit our dial bore gauge into the block. So we can use our SPI micrometer to measure the largest diameter of the rear main journal and set it to that size. Then we can use our micrometer to zero out our dial bore gauge to the journal size and take a direct vertical oil clearance measurement in the main bearings. The micrometer and dial bore gauge are individually set to each journal for accuracy, and they are all measured between 24 and 26 10,000ths.
Measuring the rod bearing clearance follows the same process, starting by torquing the rod bearing caps to achieve the proper stretch of 73 to 77 10,000ths on the ARP L19 rod bolts. Then we can set the micrometer to the corresponding journal on the crankshaft, use it to zero our dial bore gauge, and take a direct oil clearance measurement for each rod, which are all set between 22 and 23 10,000ths on this street application. Our Holley Power Pack piston kit comes with a set of file fit rings that are 1.5, 1.5, 3 millimeter thick, so the next step is accurately setting the ring end gaps with our Summit Racing Pro Ring Filer. For this application, naturally aspirated on pump gas, the top ring gaps are set to 25 thousandths and the second rings are set to 28 thousandths.
Once all the rings are fully cleaned, we can assemble the Holley pistons on these 6-700 long H-beam rods with copious amounts of Hot Shot Secret assembly lube. The pistons have a 10cc effective dome, a phosphate coating over the whole piston, and an anti-scuff Grafal coating on the skirts. The 990 wrist pins are retained by a single circlip on both sides, which can be installed with a pocket screwdriver.
Finally, we can start putting parts into our large displacement big block, and after applying some assembly lube to the main bearings, the 4750 stroke crank can be dropped in with a new one-piece rear main seal already installed. A crucial piece that cannot be missed on this Gen 6 big block is the O-ring that goes under the doweled number 5 main cap and seals the main oil feed passageway. Then each main cap can receive assembly lube and be installed in the correct position and orientation. They are tapped down with a rubber mallet. Then the main bolts can be torqued inside out to 100 pound-feet.
When installing the piston rings, we start at the bottom and work our way up. So with the support rail already installed, we can put on the oil ring expander first and then the oil control rings by hand. Then the second ring and the top ring can be installed using this Goodson ring expander. This helps evenly apply pressure to the ring and prevents twisting or bending the ring trying to install them by hand. The rings also receive a decent amount of Total Seal assembly lube to help protect them during assembly and initial startup.
We like to install the camshaft before the rods and pistons to make it easier to turn the engine over during the degreasing process. So the new bump stick gets installed next. It is a Comp Cam's hydraulic roller that we had custom ground that has specs of 263 on the intake and 279 on the exhaust for durations at 50 thousandths lift. The lobes are set on a 110-degree lobe separation angle, and the lift at the valve with our rockers is 720 thousandths on both. We also had it ground with an LS firing order, so now it is 18726543.
To reinstall the Jessel belt drive, the rear thrust washer shim goes over the cam face, and then the cam adapter can be bolted on with a small amount of silicone to prevent oil leaks. The front thrust shim can be lubed and installed before the O-ring sealed timing cover can be bolted on. Then the crank gear can be pressed on, and the timing belt with the cam gear can be wiggled on with some patience. The cam bolt is left-hand threaded and torqued to 70 pound-feet with some thread locker. To set TDC number 1 on our degree wheel, we'll just install the number 1 piston. Then we can check the intake center line of the camshaft, and for this application, a lower RPM street engine, we are advancing at 6 degrees to put the intake center line at 104.
With that set, the rest of the piston and rod assemblies can be installed using this ARP 4600 bore fixed ring compressor and a Summit Racing piston installation dead blow. The rod caps are snugged down with an impact temporarily while we rotate the engine and install the other 7 sets. And then the engine can be flipped upside down to final torque the rod bolts. The bolts are fully loosened for consistent torquing, and since we measured it earlier, each rod can be torqued down to 95 pound-feet to achieve the proper stretch.
All right, there's the engine, guys.
Hey there, boys.
What do y'all got going on today?
Well, you know, this is it's a short block form though, but it's coming really well.
Yeah,
It's looking real nice. I tell you what, we've got a project over there that we're just starting on. It's a 1989 Chevrolet truck, regular cab short bed, but it's kind of slow with that old 350 and a little small block. You know, we need something to pep it up.
A little tired.
I think this is something that would make you very, very happy.
You know, we want to play off that a little bit, maybe maybe go with the big block, LS. I don't know, but this one looks pretty good though.
You guys doing suspension? You doing tires and wheels? You doing everything? Or?
Suspension, converting the transmission to a manual.
Bigger brakes.
Nice.
Yep, bigger brakes, you know, make it a good solid sport truck.
You know, we've got it to short block form. There's a lot of work left, but pretty soon we'll be running it on the dyno, so.
Yeah, we can get this thing on the dyno, call us over, and we'll come check it out.
We're gonna light it, and then you can hear it, and you can just come running over.
Yeah, but for now, I think this is gonna be a great stopping point. Next time you'll see us wrap up this engine, get it on the dyno, and make some hot water.
And if you want to see all other things that we do cool, check out Power Nation TV.
Today on Engine Power, we are back on our 632, and we are gonna get this sexy, badass, big block power plant finished up with its induction package, a trick EFI system, and all the trimmings.
We'll fire it up, tune it up, and see what it's gonna make on our Superflow dyno, and may even have a couple of guests in to see how it runs. Hey everyone, welcome to Engine Power. We are continuing on the buildup of our 632 pump gas big block for our neighbors over in Music City Truck. It is going in a spectacular ride I think you're really gonna like. To this point, we have a functional short block. We still have a lot of stuff to do to get this thing on the dyno.
Yeah, so today we are gonna get it wrapped up. That means putting on the induction, getting our EFI sorted out, and obviously sealing it up. But while we get this stuff prepped so we can get started, here's a quick look at everything we've done to this engine so far.
You're gonna like it.
This 632 is going to become the heart of Music City Truck's newest project, an OBS Chevy truck that they are transforming into a 632 SS muscle truck, a cool twist on the classic 454 SS from the 90s. The engine was previously a carbureted, pump gas, solid roller combo, but to get it ready for this iteration, we had to tear it all the way down.
Whoa, my. Whew.
I got it. After refreshing the boards with a ball hone, we balanced the 4750 stroke crank for our new 10cc domed pistons on our CWT multi-valve 5500. The engine will also be switched over to sequential multi-port fuel injection and coil near plug ignition. So after we modified our valve covers with some coil mounts, we gave the block, valve covers, and intake a glossy coat of classic red engine enamel from POR 15.
After checking main bearing and rod bearing clearance, the large stroke crankshaft was installed, followed by the new hydraulic roller camshaft. It has specs of 263, 279 for duration at 50 thousandths, a 110-degree lobe separation angle, and 720 thousandths valve lift on both the intake and exhaust. The intake centerline was set at 104 degrees, and then the remaining 7 piston and rod assemblies went in to finish out the short block. Since we've already clearanced the new oil pump and pan gasket and checked the pickup clearance, the oil pump can drop on for real with an ARP chromoly drive shaft. The pickup is matched to our pan, and our ARP bolt holding it down is torqued to 65 pound-feet. A squirt of RTV in all 4 corners goes on, followed by the gasket, and then the new Canton Racing Gen 6 big block oil pan. It has a built-in crank scraper, kickouts, a 7-quart capacity, and is held down with the reused stainless ARP fasteners.
After flipping the block over, we can reinstall the timing pointer and then press on the ATI damper. Do not hammer the dampers on. Use a correct damper installation tool like this one to make sure you don't damage it. Okay, with our timing pointer installed, the next thing we're gonna do is set true TDC on our damper, and that is gonna be today's topic in our Summit Racing Tech Tip.
Okay, so what is setting true TDC and why do we need to do it? Well, we have our timing marks that are on our damper and we have our timing pointer that allows us to know where the number one piston is in crankshaft degrees. But there are machining tolerances in all of the parts we install in the engine, so we want to make sure that when our timing pointer says TDC on the damper, that the piston is actually at the top of its bore and the crank journal is in the center line of that cylinder. So the way we're actually going to set this is by using a piston stop. This is going to stop the piston in the cylinder at a predefined point. So you can get these at Summit Racing. We have one that bolts across the deck, and we have one that goes in the spark plug hole if you're trying to do this while the cylinder heads are installed. So for our application, we're going to use this one. So what we're going to do is run the piston a little down in the bore. We'll take this guy and gently bolt it right across the deck. And if you're doing a build with a dished piston, these have a little stop that you can run down for those as well. So because we have a dome, what we're going to do is just run the piston very gently up into our piston stop, just like that. And then we're going to look on our damper and see what our measurement is from TDC. So that is about 14 on that one. So then we'll turn the engine backwards to get the piston around on the other side. And again, bringing it up to the piston stop very gently until it touches. And on this side, we are at 15, so that's very, very close. What we're gonna do is we're gonna take the average of those two numbers, so 15 and 14, the average is 14.5, and now we can just take our timing pointer and use the adjustment to slide it to 14.5, and it will be perfectly set for true TDC. And now we have an accurate TDC setting. And the reason this is so important is mainly due to ignition timing. We want to make sure that when we're setting our timing, what we think is happening is what's actually happening inside the cylinder. Even on an EFI engine like this one, we have to set base timing and then tune from there. So this way we know we have accurate data and accurate tuning information when we're dynoing the engine. So we do this on every single engine we build. And if you need help figuring out what damper or timing pointer setup you need, or how to use the tools to set them up correctly, you can talk to the experts at Summit Racing Equipment. Coming up, we convert our 632 big block over to hydraulic roller valve train and bolt on some easy EFI induction. All right, we are continuing on with our 632 build. The next thing we're going to be doing is getting our AFR 385cc heads set up for our new hydraulic roller camshaft. These were set up for a pretty aggressive solid roller before, so we need to change out the spring pack for one that's more appropriate. We actually got it from Summit Racing Equipment, but this is an AFR spring pack. This is the one that they use on their smaller hydraulic roller heads, so we have the correct locators, the retainers, and locks for these springs. So we're gonna get these set up. Pat's already going ahead and doing some measuring. We're gonna get them on, and then we'll get these babies bolted on. These solid roller springs were set up at 275 pounds of seat pressure with 720 pounds of open pressure. Since they still have plenty of life left in them, they will be removed from the heads and boxed up to hit the part shelf. Our new locators are matched to the size of the spring, and with the matching shims we got, each of the springs is set up individually in their respective spring pocket within 5 thousandths of our 2-inch 10 thousandths target installed height.
Our new springs have a 469-pound rate and are set up at our target of 165 pounds of seat pressure and 495 pounds of open pressure. Then the heads can be reassembled, keeping the spring and shims matched to their location for accurate data. The Goodson pneumatic spring compressor makes the reassembly process quick and easy, with extra care given to ensure both valve locks are properly installed before releasing the spring.
The heads are sealed by a set of Cometic MLS head gaskets with a 4600 bore and 27 thousandths compressed thickness. Paired with the 121cc chamber on the AFR heads, we have a measured compression ratio of 11.78 to 1. The ARP head studs are installed after the heads go on to keep aluminum from being scraped into the threads and are only put into the block hand tight. The hardened washers slip on, and ARP's Ultra Torque lube is applied between the nut and the washer and on the threads. After gently running each one down with a small impact, they are torqued in an inside-out sequence in 3 stages to 80 pound-feet following ARP's instructions.
These Comp Evolution retrofit hydraulic roller lifters have been soaking in oil for about a half an hour to ensure proper lubrication and can be slipped into the lifter bores with the tie bars in the proper orientation. The Jessel shaft rocker stands are reinstalled in the same location and the same shim pack underneath and torqued to 65 pound-feet with sealer since some protrude into the intake port. The TrickFlow 3/8 diameter, 80 thousandths wall chrome moly push rods follow with high pressure lube on both ends, and the intakes are 8 350 long while the exhausts are 9 400.
The 1.8 ratio Jessel shaft rockers are installed in pairs at TDC compression stroke on each cylinder following the firing order, which with our new camshaft is the same as an LS engine, 1872653. These are a bit overkill for the hydraulic roller valve train, but there's no such thing as too accurate or too rigid valve train, and the engine was previously set up with them anyways. To achieve proper preload on the lifter's plungers, each adjuster is set 1/2 turn past 0 lash and torqued to 22 pound-feet using this LSM valve lash wrench.
New Mr. Gasket intake gaskets and delicate beads of silicone lay the setting for our custom-painted Edelbrock Super Victor EFI intake manifold, which can carefully be laid into place. With the fuel rails off, we have easy access to reuse and install the ARP stainless steel intake bolts with sealer on the threads to prevent oil seepage. With that, our induction package is sealed up and we can turn our focus to the outside of the engine. Coming up,
we get our 632's EFI system wired up to fire up.
All right, we are continuing on our 632. We're getting our valve covers on, and this is going to actually seal up the engine. So I bet it looks like we are almost done with this thing, but actually we have quite a bit of stuff left.
yeah, we have to get the whole accessory drive on because remember, this is a pump gas street engine. So our accessory drive goes on and we have to sort out and install the rest of our Trick EFI system, plus get this on a cart. So let's get to working.
This is a March Performance Big Block Chevy all-inclusive ultra-drive serpentine system, and it includes a water pump, power steering pump, alternator, and AC compressor. All the brackets and Trick covers are billet aluminum with a clear powder coat finish for protection. We lightly modified the kit to fit our Holley 36-1 crank trigger, but the Big Block specific setup is bolt-on jewelry for this show-worthy power plant. With all of the major hard parts bolted on, this 632 gets loaded onto a dyno cart and can be rolled into the dyno cell.
Now that we have our 632 hooked up to the Superflow Power Mark, it is time to bring it into the 21st century with modern EFI. We'll be using a Holley Terminator-X system on it, and this is a very complete system. It comes with the ECU, all of the sensors to run it. The complete wiring harness has an O2 sensor in it as well. Also, we have an MSD cam sync for it. No distributor in this because we are coil near plug. Also, we have a 36-1 crank trigger on it, so we have the pickup for that here as well. And we also have to put our injectors in it while it's on the dyno. So we have our rails over here with a Terminator-X injector in it that is 120 pounds per hour. Capping off this entire system is going to be a Wilson Manifolds 4500 series throttle body. It has a 2-inch throttle bore and already has the IAC motor and TPS installed in it. Now this is a lot of equipment. If we're going to get this thing running anytime soon, we better get to work. In order to add as much plenum volume as possible, we are going to use this Wilson 2-inch 4-hole tapered spacer with their 1745 CFM throttle body. These Edelbrock fuel rails are specific for their EFI manifold and use Earl's Plumbing -6 AN fittings. These dyno headers have a 2 1/8 inch primary with a 4-inch collector, and we've already modified them for our Superflow dyno's 8-channel oxygen sensors we got during our recent system upgrade. These headers are designed for a Corvette, but also work great for dyno headers, and they're the closest sizing to what the Music City Trucks guys will use on their project. For solid engine protection, we are filling the engine with 7 quarts of Hot Shot Secret 10W30 Adrenaline R3 racing oil. Before starting fresh engine builds, it is always a good idea to prime the oiling system to ensure proper oil pressure, check for leaks, and get pressurized oil through the entire engine.
Next, the MSD cam sync can drop in, and then the crank position sensor can be threaded into its mount. With the engine at TDC number 1, the sensor is positioned over the 7th tooth after the missing one, and then the air gap is locked down at 60 thousandths of an inch. The Holley Universal Coil Near Plug main harness is mostly plug and play, and our smart coils came with the matching harnesses for both sides. To try and keep the engine looking as clean as possible, we are running most of the wiring underneath the intake plenum, and once everything is connected and powered up, we can load a bass tune into the engine for its first fire up. So we should be good to go. We're gonna start out really nice and safe.
Here we go.
All right, go for it.
Light it. Woo, look at that.
There you go. Keys right up. For off the hit, it's actually pretty close. And now we have this cool live trace for our cylinders, for our O2 per cylinder, so we can watch that and get that dialed in too.
8 of them. We know what's going on in each individual cylinder, so
Yeah.
we can do individual cylinder trims
Yep.
on stuff on the EFI.
Yep.
First things first, the ubiquitous keep its guts run.
Yeah.
So we're going to make a run from 2,500 to 5,500
Yeah.
at 600 a second. Loads in nice.
Nice and safe, that's good.
And you zipped right through the pole. Nice.
Yeah. All right, I'll take that. 769 pound-feet and 775 horsepower, which power is still trending upwards because
Right.
we're only stopping at 5,500. But you can see it has a little bit of like, you know, a little bit of wave to it, and that's just because it's low on timing.
That's low
but
on timing, and if you can make a hit and it's clean through the pole on
Yeah.
the first go around, that is
Look at it.
always a win.
What I'd like to do is maybe we'll shut it down, go through
Yeah.
and go look at our eight channel Lambda, get that dialed in, and do that real quick, look at some data logs, make sure everything looks good, and then we can keep cooking.
Then we're gonna start blasting on it.
Yeah.
All right. Coming up, our favorite part. We'll see how much our 632 makes on the dyno. All right. How you looking?
Good, so we've gone through and taken all of our fuel trims per cylinder, kind of tightened them up a good bit. So as we had some that were outliers, which just happens with manifold distribution, injector sizing, things like that. So we've kind of brought them all in so none of them are unsafe or too lean or anything like that. They're all within a good range, a couple percent of each other. We've also, because we've done that, we've gone ahead and put in a few degrees of timing just to kind of get this thing a little bit more in its happy place of where it wants to be. And we're gonna see what that does.
Are you ready?
Fires right up every time.
All right, so that all being said, we're gonna put it in the real operating range of what it's being used for.
Yeah.
We're gonna start at 3,000, go to 6,000, 300 a second. Now, this is a street engine. We've had this engine before turning 7,500.
Yeah.
We've done all kinds of stuff specifically designed for pump gas run-ins. You ready?
Okay, go for it.
Here we go. That is so nice and so
Very smooth.
I love this dyno. 773 horsepower,
Yep.
780 pound-feet.
Yep, peak power is right at, looks like 5,900.
Yeah.
And peak torque, 4,700. So that's exactly what we want for the operating
That's exactly
range.
what it should be.
Yeah,
All right.
everything else looks good.
I say just on the regular
let's see.
data, everything looks great on numbers.
Yep. Being that it's a pump gas engine, I don't really want to like get after it too hard on the timing, but we are extremely safe on fuel, so I think maybe we'll lean it out a little
Okay.
bit from our target at 12.5. Probably just, we'll go straight to 12.8, look
Okay.
at the BSFCs.
I
I
know,
think we have some room there, so.
In retrospect, it doesn't sound like a big change, but you can always take more fuel out of it.
Yes, we're doing pretty good and we're getting close to where we want.
Oh, yeah,
So,
good.
Yep, go for it.
That's mean. That is 794 pound-feet.
788.2 horsepower.
This thing's, I think I know what it's gonna do.
That's,
and,
almost 800 pound-feet.
Oh, those look nice.
Those look pretty good. Now that we're, making adjustments, we can go back through and kind of fine tune this, but like what we're looking for on the 8-channel Lambda is that we don't have one that is way out there. So if we're targeting, 12.8, we don't want one that's at 14, because that cylinder could go a little bit lean, get into detonation earlier, and potentially hurt itself before all the others.
So we want to go get the guys to get over here, and
I'll go grab them so they can see their beauteous big block.
all right, I'll wait.
You guys are definitely going to want to see this, so I figured we'd
I'm
come
excited.
get you.
Sounds mean.
Yeah.
Rowdy.
Nothing sounds better than a big block.
All right, so we have running engine, right? How do you think it sounds? How do you think it looks?
I think it's going to be pretty nasty when it's in the truck. So far, I'm very happy. What about you, Mike?
Yeah, it definitely sounds mean. It looks killer. Y'all done a great
I
job.
probably seen it come over earlier because we've been running it, and I know you can hear it.
Yeah.
I know you can hear it.
I was like, we got to go get those guys because we know they're going to want to be here at least for one pull. So
okay, so this one we crept a little bit of timing in it.
yeah,
and,
yep, we bumped it up to 34 degrees and just leaned it out just a smidgen. This is kind of like our, not a Hail Mary pat pull, but kind of a Hail Mary pull just to kind of see if we can squeeze a little bit more out of it.
I think we get a little bit out of it.
Yeah.
Let's see. All right, here we go.
Do it.
That is mean. Okay, so we have 812 pound-feet
And 806 horsepower.
806 horse.
Yeah.
But like smooth curve.
I mean, when people don't understand, look at the torque down low at that low
3,000 RPM. I mean, we'll go over here. It's making 645 pound-feet.
Right. I mean, it's making over 600 pound-feet everywhere on this graph, but it just has a nice curve that carries all the way through, and it's making peak torque at 4,500 RPM.
Yeah. This is at operating temp. This is what it makes.
Yeah.
Full accessories, full street trim. So.
This thing should, run and drive like Miss Daisy's Cadillac, but be mean
Just a
when you
little
stomp the
rowdier.
pedal. Yeah.
Play your cards right. We may take you for a ride.
I hope.
Only if we get to drive.
Yeah. Hey. May be able to arrange that.
All right, we're
Awesome,
gonna get her shut down. We're gonna go through our normal checks and over to you it goes.
Have it ready.
Sounds good, boys.
Thanks, guys.
Awesome.
Appreciate
Thanks,
it.
guys. Yeah.
Good job.
Can't wait to see it.